Okay, hello and welcome to part 2 of the OLNA Numeracy Assessment Practice Assessment walkthrough. I will be showing you through questions 16 through 30 today, and then the next video will complete this OLNA Numeracy Assessment. So if you haven't tuned into the first video, we go through questions 1 to 15. There'll be a link to that in the description below. It's worth doing that video first. And the idea of this video is, of course, to bring up this page here, and complete the practice assessment and refer to this video when you need help with a question. You can also complete the assessment alongside the video and follow the steps that we show you. So without further ado, let's get into question 16. Okay, so question 16 reads, Pam started work at 3:45. She finished work 7.5 hours later. What time did Pam finish work? So the first thing we should really be doing when we have a question relating to time, I find the way I can do this and simplify this is to try and interpret 7.5 hours, because we have 0.5 hours, but what does that mean in minutes? Because that's how it's going to help us when we're trying to work out time. So 7.5 hours, we know, is actually the same as 7 hours and 30 minutes. It's important that you don't make the mistake of saying 7.5 hours is 7 hours and 50 minutes. Thinking half 0.5 is half, so half an hour is 30 minutes. So we've been asked what time did Pam finish work? Well, 3:45. 3:45 is actually 3:45, because 3:45 is 3:45, so 3 hours and 45 minutes. So we need to add 7.5. So the way I approach a time question myself is I'm going to add the minutes first and then add the hours. So if I add the 30 minutes onto 45, what does that give me? Well, 30 plus 45 gives me 75. So I'm left with 75 and 3. Now, if we interpret this for a minute, we can't have 375. That's not a time. So in actual fact, what's happened is we've gone past 4 hours. So we need to work out how much past 4 hours we are. We know if we ended up with the time 3:60, 60 minutes in an hour, we'd be at 4 o'clock. So 3:75, as it were, is 15 minutes past 60 minutes. So we must say we've got to 4 o'clock and an extra 15 minutes. So 3:60 got us to 4 o'clock, and then there's 15 more from 60 to 75 that must fall in the minutes. So it's now 4:15. We still have to add the 7 hours. We can add the 7 hours simply to this number. We go 4, 5, 6, 7, 8, 9, 10, 11. We're in the 11th hour if we add 7 to 4. So we're going to say it's 11, and the minutes don't change because we're just adding hours, 15. So Pam finished work at 11:15. Awesome. So while we check this answer, let's just iterate what we iterated in the last video, that the important part is of the OLNA is going to be to read the question, understand the question, and then think about, well, what do I know that will actually make this question answerable? Because if I didn't go through and convert 3:45 into 3:45, and if I didn't convert 7.5 hours into 7 hours and 30 minutes, it would have been quite a challenging question. So it was really important that we did that conversion first. Let's move on. Greg was asked to polish the floor of a local town hall. He made this diagram to find the area of the floor in square meters. So key bit of information there is find the area of the floor. So we've been shown on the diagram that we've got the floor and the stage. So to me, what I hear straight away is we need to find the area not including the stage, because we've just been asked for the floor. So again, the importance of reading the question. Which expression should he use to calculate the area of the floor? Well, we've got 4 options, and what did we decide last video when we have 4 options that we sort of need to check which one's right or which one's wrong? Well, we're going to evaluate all of them and see which one gives us the right answer. So in this case, we're looking for the one with the right answer. It's important to pay attention to the question, because sometimes it'll actually say what expression should he not use, or what expression does not give the area of the floor. But in this case, we're looking at an expression that gives the area of the floor. Before we can actually do that, we need to work out what the area of the floor is ourselves by using the diagram. We've been told here in the key that one box or one length here is 2 meters. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we have a length of 10. Let me just take a snip of this actually so I can show you. We have a length of 10. Oh, let's just move this up. Cross that out. We have a length of 10. But each of them represents 2. So there was 10 units, but they're each worth 2. So 10 times 2 equals 20. And I have a width of 1, 2, 3, 4, 5, 6, 7, 8. A width of 8. Remembering they still equal 2, so I need 8 lots of 2 because there's 8 units. Each of them represent 2. 8 times 2 is 16. Okay, so you'll notice as well, I didn't include the length of the stage. I took it up to here and to here because the area I'm trying to find out is within this box, not including the stage. So I treat this like its own little rectangle and I do the length and the width of this rectangle, not the stage. Right, what's our formula for calculating the area of a rectangle? Well, it is area A equal length times width. We've just found our length and our width by counting it up and multiplying it by the scale of 2. So now we're going to substitute A equals L, we're going to say is 20. It doesn't actually matter what order you put it in. L is 20, width is 16, and we need to work out 20 times 16. Let's use our commutative strategies that we know. What can we do when we have a 0 on the end of a number that we need to multiply? Down here, what can we do? We can drop the 0, can't we? And do 2 times 16 and add the 0 back later. So 2 times 16 is nice and easy. That's 32. So we start with an answer of 32. But because we dropped that 0, we have to add it back. So we say 320 instead of 32. And we're obviously going to, just for the sake of it, we need to make sure we say meters squared because it is a square measurement because we're calculating an area. Okay. So we need to go through and evaluate these and see which one actually gives us the correct answer. So let me cordon off a little section to do that. Change our color back. All right. The first one, 10 times 8 times 2. 10 times 8 times 2. That equals 80 times 2. And 80 times 2, or I can do 8 times 2, 16, and add the 0, 160. So that one is not the right answer because it doesn't give us that 320. Try the next one, 10 times 8. For this one, 10 times 8, well, we can do 1 times 8 and add a 0, 8, add a 0, 80. Definitely not the right answer, even further. This one, 20 times 16 times 2. 20 times 16 times 2. Now I'm picking up on this based on what we did here. I know that this one's wrong because I know that 20 times 16 got me the answer, not 20 times 16 times 2. I know 20 times 16 from down here to be 320, and I can use that strategy where I drop the 0. And 320 times 2, I'm going to convert that to 32 times 2, dropping my 0 again and adding it back. 32 times 2 is 64. And add back our 0, far too much. So that's the wrong answer. So we're almost sold on 20 times 16 being it. And in fact, we can say that 20 times 16 is the answer because that's the same calculation we did down here. 20 times 16, drop the 0, 2 times 16, 32, add the 0, 320. That's the correct answer. Now, there would be a quicker way to do this. The way I'm showing you is the fail-safe way. If you're not sure, if you're not confident with this style of question, this is what you should do. It might take you a little bit longer, but you will 100% get it right if you do it like this. I could have actually looked at this and said, okay, they're the dimensions. I use 20 times 16 to get there. One of the answers is 20 times 16. That must be the right answer. That's great if you can do that. If you can't, if you don't pick that up as quickly, just go through this method. There's no harm in doing the working out. Click, check, and next. Okay, Leanne and Marie met at the corner of Light Street and Main Street. They walked north along Main Street, then southwest along Lane Park to get to Light Street, and then straight back to the corner of Light Street and Main Street. The path is shown below. So we can actually see. So this information is basically just depicting what's in the image. They walked north along Main Street. So this is them north along Main Street. Well, this isn't really north. Oh, yes, it is. It is north because we've got a compass bearing orienting us. You see how this arrow points that way? That means that way is north. This map is off center. So they did in fact walk north, even though it looks like north east. So they walked north along Main Street, southwest through Lake Park to get to Light Street, and straight back to the corner of Light Street and Main Street. What direction did Leanne and Marie walk along Light Street? Well, if we're paying attention to the orient of this, it's oriented that way, so north is this way. Let me do a snip of this again and I can show you exactly what I mean. Snip, cross that out, paste it in. Let's just blow it up a little bit so we can see. Lovely. So we've just been asked, what direction did Leanne and Marie walk across Light Street? Well, as I said, this way is north. This way, because the arrow is pointing that way. So I can draw a rough compass in. How do I remember my bearings? Never eat soggy wheat beaks. Some people use never eat sour worms. There's all sorts of things you can use, but it's NESW, north, east, south, west. Never eat soggy wheat beaks. Now, based on this, I can see that along Light Street, they have walked east because they're in the same direction as the east marker. So I can say east. This is more of a comprehending question, this one. And next question. Anna works as the chef. She is currently earning $1,200 per week. Anna will get a 20% pay increase next week. How much more money should she get each week? I'm going to show you two good methods for this. Let me show you the good method. When you're doing percentages in the OLNA, the chances are you're going to be faced with percentages that, well, not the chances are, you're going to be faced with percentages that you can do in your head or with a bit of paper. You may not necessarily need a calculator. Arguably, this will be a lot easier with a calculator, but we can solve it. We have to look at the percentage because one thing I know how to do is find 10% of any number, because 10% of any number, you simply just reduce the place value. So because she was currently earning $1,200 a week, if I want to find 10% of that, I know I've been asked for 20, but I want to find 10% first, I simply cross out a zero or reduce a place value by taking my invisible decimal point and jumping over here. The new number is 120. So $120 is equal to 10% of this value. Okay? We've been asked for the 20% pay increase. So if 10% is 120, let's have a think. What could 20% be? How did I just turn 10% into 20? I've doubled it, haven't I? What's the rule of equations? Whatever you do to one side, you must do to the other. So if I can double 10 to get 20, I must double 120 to get the new number. So 120 times 2, well, drop the 0. 12 times 2, 24. Then add your 0 back, 240. Nice, easy one. Remembering that the question's asked us how much more money should she get, so we have found the correct answer. We just want to be wary on these sorts of questions because it might ask what's her new weekly wage. And then obviously if you say 240, that's wrong because that's how much extra she gets, not her new weekly wage. You'd have to add 240 to 1,200. But we have been asked how much extra, so we can safely press 240. Next. An Australian family is planning a holiday in Bali. They have been told that the exchange rate is 1 AUD or 1 Aussie dollar, we call it, is equal to 10,000 rupees. If they want 1 million rupees, how many Australian dollars should they exchange? This is a game of place value. Let's write a million down here. A million has 6 zeros, 1 and 6 zeros. Sometimes it helps to use a comma to space it out. I don't usually like using commas because I confuse them for decimal points sometimes, but sometimes a comma will just help you write down the million. I'm going to actually delete my commas so I don't get confused. Okay, how did we arrive at 1 million? Well, how many more zeros is what we're asking. Does a million have than 10,000? Well, this one has 1, 2, 3, 4. This one has 1, 2, 3, 4, 5, 6. So if there's an extra 2 zeros, the way I've added 2 zeros is by timesing it by 100. Because whenever we times by 10, 100, 1,000, 10,000, we add the amount of zeros on the number to the number. So if I've added simply 2 zeros to get a million, I must have times by 100 to move these 2 zeros onto it. So using the same equation logic as we used the last question, whatever we do to one side, we must do to the other. So what can I times this side by? That's right, we can times it by 100. And 1 times 100, that's a nice easy one, is 100 Aussie dollars. Correct, so we can select 100 Aussie dollars. They wanted 1 million. Just before we submit, we're checking. They wanted 1 million rupees. We did 1 million rupees. Looking for how many Aussie dollars. We found that out. Fantastic. Check and next. So we're always checking our answers again before we submit. So reread the question once you've submitted an answer, or once you've chosen an answer. Reread the question just to make sure that was the right answer, because you may well be correct in the maths, but the question might have been asking for something different. I can't stress that enough. You must reread the question. Stan is the best player of the Hills basketball team. He played 17 games last season. This graph shows the points he scored in each of these games. This is a dot plot, or it's similar to a bar chart, but it uses dots effectively. Select the 2 statements that are true. So we're trying to select 2, so don't forget to select 2 and make sure that they're true ones. We're not selecting the false ones, we're selecting the true ones, but make sure we select 2. So easy, I know it sounds obvious, so easy to accidentally press 1 and submit and get that question wrong. So let's have a look at the answers. Stan's lowest score was 14 points. Is that true? It is. Why? Why wouldn't it be 16 or 18 or 20 or 22? These have got less dots. Well, if we really read the graph and we interpret it, along here is how many points, and each dot is a frequency. So what it means is, out of his 17 games, 2 of those games, 1 and 2, he scored 14. 4 of those games he scored 15. 1 of those he scored 16. We need to make sure we interpret the graph like that. So that comes down to reading, looking, analysing and understanding the graph before we answer. So this is actually a true point. Stan's lowest score was 14 points, as illustrated here. Stan's highest score was 25 points. Is that true? Well, there's 25 up here, so must it be? No. Why not? Well, it wouldn't be his highest score, because although the graph, the scale goes to 25, he hasn't actually got a dot on 25, meaning he didn't achieve 25. The high score was in fact 22, because 23, 24, 25 don't have a dot on them. So he didn't actually score that many. So that's false. Stan scored less than 20 points in most games. Well, to validate a most, we need to make sure we've got more, basically. Most means more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of the games he scored less than 20 points. 1, 2, 3, 4, 5. So yeah, that is true. Just to be sure, let's have a look at the final point and make sure it's not true also. Stan scored more than 19 points in only 3 games. More than 19 points in only 3 games? 1, 2, 3, 4, 5. No, he scored more than 19 in 5, so that's false. So we're confident in these 2 answers because we've checked all of them, and these 2 are the only 2 that are correct. Check and submit. Alrighty, the shoes Fred wanted to buy were originally priced at $63 at a shop. Now the shop has a sale with a third off everything. How much should Fred pay for the shoes if he buys them on sale? Great. So we're trying to find what is a third less than 63. So mistake we could often make is reporting the answer as 1/3 of 63. No, the answer is actually 2/3 of 63. Because we have a discount of one third. So if we have the whole value, 63, just to show you what I mean, 63 is actually the same as 3/3 of 63. Because 3/3 is the whole. One whole 63 is 63. If I have a third off everything, let's take 1/3 from this. That gives me 2/3. So 2/3 equals 63, but with a third discount. So I need to find 2/3. What could actually be easier is finding 1/3 to begin with and then timesing it by 2. So what we're going to do is that 1/3 of 63. We achieve that by timesing 63 by a third. And when we times together, we just, to help us out, we put 63 over 1 because any whole number over 1 is just itself. So 63 over 1 is just 63, but it makes it a bit clearer when we're timesing. So let's do this fraction multiplication. We need to times the top numbers and times the bottom numbers. 1 times 63 is 63. 3 times 1 is 3. So we're left with 63 over 3. What that actually means is 63 divided by 3. So how can we divide 63 by 3? Well, what we need to do is we need to figure that out. Let's use a strategy. I know that 10 times 3 is equal to 30. That means 20 times 3 must be, what must it be? 60, because we're doubling. 10 doubled is 20, so the answer must double. How many more 3s are in 63? Well, 1, isn't it? Because 20 go into 60. 1 more to get to 63, so we must be looking at 21. That's the answer to our division. That's not the answer to the question, though. We were asked for a third discount, so we need to find 2/3, as we discussed. Another way you could do it is by taking 21 from 63, but I think it's easier to just find the 2/3 and go 21 multiplied by 2 to find the 2/3 instead of 1/3, and that's equal to 42. Select your answer, check your answer, submit. Okay, question 23. The famous Australian horse Phar Lap raced in the early 1930s. Phar Lap's heart was 6.35 kilograms, while the heart of an average horse is 3.5 kilograms. How much heavier is the heart of an average horse with Phar Lap's heart? Okay, so we basically want to work out the difference between 6.35 and 3.5 because the difference will give us how much heavier because, argument's sake, the average horse is 3.5, Phar Lap's is 6.35. We're asked how much heavier is it, so how much more is it? Well, doing a subtraction will find how much more from here to here, the difference between them. So let's do that. I think the best way to approach this one will be vertically. 3.5, 6.35. And let's put a 0 there to hold our place value. Let me just erase this so we've got a bit of room to work with. Fantastic. So, how do we do a subtraction like this? Well, we do it vertically. We do 5 take 0 is 5. 3 take 5 we can't do, can we? 3 take 5 we can't do. That'll give us a negative. We can't use a negative here. So, we have to borrow. Remember when we borrow, we cross, change that to 1 less, so 5. And we add a 1 here to make it 13. So 5 take 13 now, or 13 rather take 5. 13 take 5 is 8, that's right. Keep your decimal in line. 5 take away 3 is 2. So we found the answer to be 2.85, and we've got that here. So click, check, fantastic. Next. Ellie wants to put a border around the grass at the front of her house. The length of the front wall of her house is 10 meters. How many meters of border does Ellie need to buy? Okay, so the interesting thing here, we need to pay attention to the fact that they've asked for just the border, which is given by this brown. The key shows it, given by this brown color. Looks like a fence. We don't need to find the distance of the wall. So effectively, what we've been asked is for the perimeter of this shape, perimeter meaning the distance around the outside, but not including this side, because we don't want to buy wall for the, we don't want to buy border for the wall, because what's the point of putting the border in front of the wall? It doesn't make any sense. So let's find the perimeter. We don't have all these sides, so we can use a strategy to find that out. Here's an interesting strategy. Let me screen snip and put it over on our little whiteboard so we can do this a little bit easier. Fantastic. Cross that off and blow this up. Come on. There we go. Alrighty. We've been given this side as 10, this side as 6, but we've been missing this side and this side. So here's a strategy to help us find them. I say that this side and this side, let's just draw this up here because this is the measure of that side, make up perfectly this side together. Because if we're finding perimeter, I don't actually care what this side is and this side is. I just want to know what the total is. So I can actually just add 10 and that'll cover this side done and this side done. So let's say 10 plus, well, we know this side already is 6. And let's apply that same logic. We know that this one's 2 and we don't know this one, but I know that together they form 6 because they fit into each other. If we bring this out here, we have this side as 6. So I'm going to add another 6 to check off that side and that side together. And we've obviously added this 6, that side's checked off. That's all the sides we need. 10 plus 6 plus 6, well, 10 plus 6 is 16. 16 plus 6 is 22. Fantastic. And we've got an answer of 22. Check. Next. Bananas are the favorite energy food of many athletes. Energy can be measured in calories, cal, or kilojoules, kj. A large banana has 120 calories. How many kilojoules will 10 large bananas have? Okay, we're looking for the kilojoules in 10 large bananas. So what we'll do first is let's find out, because we're looking at the question and we're saying, all right, they've given us one large banana at 120 calories, but we've been asked to find 10 large bananas in kilojoules, not calories. So we first should convert calories to kilojoules, and then we can multiply it by 10 for 10 large bananas. So how do we convert 120 calories into kilojoules? Well, if we've been told that 1 calorie is approximately 4 kilojoules, then what operation would we need to do? Well, I have to times 1 by 120 to get there. So I have to times 4 by 120 also. So 4 times 120, let's work that out. That's equal to, well, 4 times 12, 12, 24, 36, 48. And add that 0 back that we dropped, 480. So there's 480 kilojoules we found by using our equation laws and knowing our rule of equivalence. 480 kilojoules, not calories, in 1 large banana. But I wanted it in 10 large bananas. So how do I times by 10? Well, 10's got 1 0, so I just add 1 0 on the end of 480. So the answer becomes 4,800. And that's one of our answers. Check. Fantastic. This is one, and I've done this question with students many times. This is one that you need to read a couple of times because there's quite a few layers. The layers being the conversion to kilojoules, and then also knowing that we were looking for 10 large bananas. And they try and trick you out with the answer because they give you all these answers that could possibly be ones you'll select. So like 480 could be the answer if you forgot to times it by 10. 4,000 could be the answer if you just saw this as 100, not 120. And they're just trying to trip you out. So make sure you read this one really carefully, or this sort of question, or all questions really carefully, because they can trip you up. Question 26. Scroll that down. Theo planted 4 types of vegetable seeds. Most of the seeds he planted produced seedlings. Here's our table. What percentage of the radish seeds produced seedlings? Okay, well, we've got the the radish column here, and it said that there was 40 seeds planted. So there was a total of 40 seeds planted of radish seeds. That's not a very nice 0. Let's make a better 0. Lovely. Out of the 40 that were planted, 30 produced seedlings. Number of seeds that produce seedlings, 30. So what we could say is 30 out of 40 produced seedlings. Am I right? Like if you got 30 out of 40 on a test, you do 30 over 40. So 30 out of 40 produce seedlings, so 30 over 40. Now that we've got that, we can work out the percentage. Now the best way to work out the percentage is going to be through a little bit of logic and reasoning. And what I mean by that is, I know that 30 over 40 is the same as, pardon me, 3 over 4. Because what I can do is a concept called cancelling. I can cancel zeros. Because there's a 0 on the top and the bottom, I can cross them both out. That's because I divided the top value and the bottom value by 10. But to simplify it, you just cross the zeros out. Remember, if you do this, you can only cross the same amount of zeros on the top and the bottom. So if I had 300 over 40, I could only do that. I couldn't cross this one out because I have to cross the same amount out on the top and bottom. Awesome. All right. Now that we've got 3 over 4, what is 3/4 of 100? What are 3/4? 75%, right? 75. So the answer is 75%. Another way you can do this is you can try and bring this number to 1 or 100 or 10 and then work it out that way. But I just look at this and I say, well, 3 over 4 I know is 75, because if I break 100 into 4, because remember 4 parts, so we're dividing into 4 parts, I know that 100 divided by 4 is 25. And if I've got 3 of those parts, well, I'm doing 25 times 3, which is 75. So that's how I figured that out. So we can confidently say 75. And there's a part B to this question. Theo rated the success of a vegetable by the percentage of seeds that produce seedlings. Which was his most successful vegetable? Okay, so without a calculator, the best way to do this is look through and just roughly work them out, okay? We've got, I might just make some more room for us. We've got 4 different plants, 4 different vegetables, and we can work out the efficacy of all of them. So I'm going to start with onions. Onions, 40 seedlings produce seedlings out of the 50 planted. 40 produce seedlings out of the 50 planted. I can use that strategy where I make the bottom number 100 to find this one. How do I get 50 to 100? Nice easy one. You times it by 2. The law of equation, times by 2. 40 times 2 is 80. 80%. 80 over 100 means 80%. So they had an 80% efficiency rate. So already that's better than the radishes, because the radishes, so this was the onions, and the radishes, they had 75%. So already onion is in the lead. Turnips, 7 out of 10 produced seedlings. 7 produced seedlings, 10 were planted. Nice easy one. Anything out of 10, 7 out of 10 just means 70%. That's even lower than the onions, so the turnips don't make the cut. But the carrots, 78 of them produce seedlings out of the 100 planted. Another nice easy one, 78 out of 100 is 78% for the carrots. So now we've worked them out. Which one's the largest? Which one has the highest percentage? Because, argument's sake, the highest percentage will give us the most successful vegetable. It's the onions, right? Yeah, because 40 out of 50 produce seedlings. So we're going to click on onions. Now, here's a little sort of query for you. Why wouldn't it be carrots? Because carrots clearly has more seedlings that produce, more seeds that produce seedlings. Whereas onions only have 40, they've got 78. It's all to do with how many were planted, because we planted a whole lot more carrot seeds. So if we sort of work it out as a percentage, what it shows us is, well, I guess per seed, or what the actual efficiency is, because you've got to compare how many seeds were planted, because it's not fair if we planted 1,000 seeds of one thing, 10 seeds of the other, and then the 1,000 seeds produce 2 seedlings and the 10 seedlings produce 1. Well, the 10 seedlings are still more efficient than the 1,000 seedlings because we planted 10 times more. but only got one more seedling. So we've got to do it proportionally. Let's check our answers and submit. Simon bought hexagonal pavers for his courtyard. He needs pentagonal pavers to make a straight edge along the fence. Which of these cuts through the hexagonal paver will produce a pentagonal paver? Well, we need to know what hexagonal and pentagonal mean. Hex means 6 sides. Hexagons have 6 sides. Pent or pentagonal means 5 sides. Pentagons have 5 sides. So we need to turn this shape from having 6 sides into 5 sides. So let's take a snip of this. Snip. And let's just explore the shape that will be formed. This one's actually not a tricky one. You should be able to get this one. Cross that out. Okay. If we were to cut along this line, what they're saying is, what happens if we cut? Well, if we cut along this line, the new shape formed is this paver. One side, 2 sides, 3 sides, 4 sides, 5 sides. So that is a pentagon. So we can click that one. But we've been asked for all the options. So we've got to find all the ones that produce pentagons. Let's have a look at this one. This one's right down the middle. 1, 2, 3, 4 sides. So that one's not. And we've got the same shape because right down the middle. 1, 2, 3, 4. So that's not a pentagon. Neither of them are pentagons. They're simply what we call quadrilaterals. They've got 4 sides, quad meaning 4. This one's very similar to the one up there, but there's something astray. They haven't taken it to the corner like they did up here. So what happens is this. We have 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides. Because we've kind of introduced another side by not taking it all the way up. We've got this little side here that still is a side. So that's got too many sides. 1, 2, 3, 4, 5, 6. That's still made it a hexagon. And this one has only got 1, 2, 3 sides. That's only a triangle. Okay. This one, we cut here. We've got 1, 2, 3, 4, 5. So that's made a pentagon. And this one's just a 1, 2, 3, 4. That's a quadrilateral. This one's a pentagon. But it's still made a pentagon. So we can tick it because it made a pentagon and we can click it over here. Check, correct, and next. So it's always good to just visualize these ones. Peter wants to buy some spring water from her local shop. The shop sells spring water in single bottles, in packs of 4 bottles or packs of 8 bottles. Peter spent $16 buying spring water, which could not be true. Best thing we can do is go through all of them. She spent $16, has to be $16. Not less, not more, has to be $16. So let's go through and check all these answers. Peter bought 16 single bottles. Well, one single bottle is $1, and she bought 16 of them, so 16 lots of $1 is $16. So that one's correct, but we're looking for the one that's not true. Peter bought 3 packs of 8 bottles and 1 single bottle. So 3 packs of 8 bottles, which cost $5 each. 3 lots of $5 is $15. And she also bought 1 single bottle. So we're adding on just $1 for that 1 single bottle, because that 1 single bottle costs $1. 15 plus 1 is 16. So this one's also correct, but not the right answer because we're looking for the one that's not true. Peter bought 1 pack of 8 bottles and 3 packs of 4 bottles. Well, 1 pack of 8. Oops. 1 pack of 8 costs $5. So 1 times 5 is 5. Added with our 3 packs of 4. 3 packs of 4 bottles, which were $3 each. So 3 times 3. That's 9. 5 plus 9 is not 16. 5 plus 9 is 14. So this one is wrong, but right in the context of the question. Let's just double check this one. Peter bought 2 packs of 8 bottles, so 2 lots of 8. 2 times the $5 for an $8 bottle, an 8 bottle. $10, and 2 packs of 4 bottles. 2 packs of 4 bottles. 2 times the $3 it costs for the 4 bottles. 6. 10 plus 6 is 16. So this one is also correct, but wrong in the context of the question. So we're looking at this one being correct. Check and next. Frank measured his pulse before jogging. He counted 6 beats in 5 seconds. What was his pulse rate in beats per minute? Okay, he got 6 beats for 5 seconds. How many seconds are in a minute? Well, 60 seconds, isn't it? So how do I get 5 to 60? Remember, we're using this law of equivalence. What do I times 5 by? I times it by 12, don't I? So what should I times 6 by to work out the same? Should times it by 12, shouldn't I? 6 times 12, well, let's break it up. 6 times 12 can be broken up into 6 times 10 and 6 times 2. 6 times 10 is 60. 6 times 2 is 12. Add the results, we get 72. So what we're saying is there's 72 beats per 60 seconds. In other words, 72 beats per minute. Select 72, check answer, and next. Alrighty, and the final question we're going to look at today. Joan checked the weather forecast at 6:30 in the morning. The forecast showed the likelihood of rain as a percentage. Select all the statements that are true. According to the forecast, it is certain that it will be raining at 7 a.m. Yes, that's correct. Why? Because at 7 a.m., it shows a 100% chance of rain. 100% chance means it's absolutely certain. So we have to tick that. Unlikely that it will be raining at 9 a.m. 9 a.m., a 30% chance of rain? Yeah, I agree. It is unlikely that it will be raining at 9 a.m. It's not impossible. There's a pretty low chance though. 70% chance it won't rain and 30% chance it will rain. So we'll tick that one as well. Unlikely that it will be raining at 10 a.m. Well, at 10 a.m. it's showing a 60% chance. So it's actually likely. It's not unlikely, it's likely because it's more than 50%, more than half the chance it's going to rain. So we can't tick that one. That one's false. Likely that it will be raining at 11 a.m. 11 a.m. Yep, there's an 80% chance. So that's true because 80% chance is very likely that it will be raining. Click, check, and next. Okay, so that concludes this video. We've gone through questions 15 through to questions 30, or 16 through to 30, I should say. If you've enjoyed, please leave a like and don't forget to subscribe, as we'll be uploading more videos on this topic, as well as other videos to help you with your school content. Thank you very much and good luck. We'll see you in the next one. Thank you very much and good luck. We'll see you in the next one.